Bioinformatics.
Okay, so in this lab follow along, I'm going to talk a little bit about how to use R just in general for those of you that have not used it before. To be honest, if you have used R for research, some of this will be review, and feel free to kind of just skim through it. If you understand how to change working directories, how to import data frames, and do some basic manipulations of the content within data frames, you probably already know more than I'm going to cover in this lab. But because we're going to be doing differential expression analyses coming up, and those are implemented for the most part within R, it's important for those of you that haven't used R before to get a little introductory familiarity with it. And so rather than developing something from the ground up for this lab, there are incredible resources on how to use R as a biologist through data carpentry. And so really all I've done is very lightly modified some of the introductory materials that they provide open source to anyone that wants to look them up and use their materials to make it a little bit more in line with the bare minimum I need you guys to know. And so let's walk through this. I'm not going to go through all the reading because you're going to be doing that on your own, but I would like to show you the basics of how to work within an R interface. And so what you can see here, just to orient you, I have here this thing called the console, which is where you can input R commands. For example, you could do 3 plus 5 and hit enter and get 8. You can also, and I'll close what I have right now, make an R script. And this is how I exclusively use R and strongly suggest you as well. You can hit here to make a new file and make a new R script. It's going to pop up here, and what it is a text editor. But it has some other features to it that are really nice. I could write 3 plus 5 here, and spaces don't matter, so you could do 3 plus 5 here as well. Now, rather than typing it in down here, what I can do is, if you're on a Mac, you can hit Command Enter. I believe it's Control R if you're on Windows, but double check. And it will automatically send whatever line I'm on. I don't have to highlight it. I just have to be on a line. Doesn't matter if I'm at the beginning or if I'm at the end. If I hit Command Return, it will send that code to the console as if I had typed it live. Why is this nice? Because I can make whole long scripts with lots of commands, and then I can edit them if I find there are problems or tweak them to accommodate different types of data, and then save these scripts and keep them as like a library of how to do things. I could even highlight the whole thing if I wanted and hit Command Return. Now, those aren't valid R scripts, so it's going to get mad at me, but I could hit Command Return, and it will send line by line to the console. So this is how I strongly recommend that you interface with R. So let's walk through this lab using this within the framework of an R script. So we did 3 plus 5 and executed that. So you can do basic math in R. You can do division, 12 divided by 7, and see that down there. But you can also store the output similar to how we use variables in the shell as objects, as R calls them. And so if we want to store some content as an object or a variable, we use this funny little arrow. Now what this arrow is basically a less than sign and a dash. And all the contents on the right side of the arrow, when it's facing this way, will send their values into wherever the arrow is pointing. So we could say 55. Now we could put whatever we want here and it will become equal to 55. So we could say weight in kilograms, for example. Now if we execute that, we're just going to see that this object was stored with the value of 55. We're not going to see the output of any of these commands. But we could recall the value of this object by executing just the name. And here we can see the value is 55. This is a good time to point out that you can use tab when you're within R Studio to autocomplete things. So if I start typing weight, I can hit tab, or it'll actually sometimes just pop up and I can go, oh, did I mean the command weighted mean? No, weight underscore kilogram object is something that I wanted to autocomplete. Okay, so that's actually really quite nice. Moving down, we can perform math on our objects. So if we had weight kilogram, we could multiply it by 2.2 if we wanted. Okay, and that's 50. It's basically the same as doing 55 times 2.2, which is 121. You can even overwrite the value, let's say you were doing some analysis and you went, you know what? Actually, I went back and reweighed it and it was actually 57.5. Well, you could just execute that to overwrite it and then work your way down and execute through your script again and see that now the output is different because we changed the value of weight kilogram. R has something called functions. Just like objects are similar to variables, they are quite different in many ways as well, but for the sake of this class, they're similar to variables. R has functions, which are very similar to the commands that you've become familiar with in the shell. You can have default functions that are built into R, base R basically. You can also install new packages, which are similar to the things that you installed using conda in the shell to get more functions or commands at your fingertips. You modify functions using arguments just like you modify commands in shell, although the formatting is slightly different. So let's start with a really basic one. There is a function for square rooting a number. We could, let's say we'll make a object or a variable a equal to the number 4. Now we could use the function square root. Now the format for using functions in R versus using commands in shell is that the function is always followed by parentheses, and then you put whatever the arguments or values for it to operate on within those parentheses. And so in the case of square root, if we want to find the square root of our object a, we would put the a within the parentheses. And I'll show you how you know where to put it in a second. Now if we execute this, we'll see that the square root is 2. You could also save the value as b. So now if we executed this, a is 4 and b is 2, because b is the square root of a. Let's go ahead and try and look at one more function. So in this case, round does probably what you think it does. It rounds a value. So let's just round part of pi. So 3.14159. We could just round this, and it rounds it to 3. Okay? Well, that's kind of nice, but what if we wanted to round it a different digit? Well, this is where looking at what the function's arguments are can be useful. So we could look at we could use the function args to look at what arguments are available to round. And this can sometimes be helpful and sometimes not very helpful. If we look here, the function has the arguments x, which is basically your input value. So in this case, it was 3.14159. And then you can have digits equal whatever. And it will show you what the default value is. So the default value is it's rounding to 0 digits, which is why it rounded to 3 from 3.14. So we could change what digits are equal to, though. So we could set digits equal to 2. So we could say round 3.14159, comma, because here the arguments are separated by a comma rather than just a space as in the shell, digits are equal to 2. And now if we execute that, it rounds to 3.14. If you wanted to see more info about round, you could put a question mark in front of the function. And on the right, at least if you're in RStudio, I've got this kind of minimized, but you can pull up the whole basically the manual, the equivalent of Manning round, to look at, oh, well, here are the different arguments. X, it has to be a numeric vector, blah, 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 blah. Digits, it has to be an integer. You can read all about all these different functions by putting a question mark in front of them. Now we're going to talk about how to bring in a data frame. This is R's version of a table, basically. But it can also be a table with much more functionality than you would typically see in Excel. And working within data frames is really, I think, one of the primary reasons people start to work in R, because you can do a lot more things than you're able to do in a typical spreadsheet manager like Excel or Google Sheets. So we're going to be importing a really basic data frame that's similar kind of in shape and size to something that you might experience working with gene expression data. And so this is going to have a number of columns, and you can see what the descriptions of every column is. It's not really important for that you understand this, but know that we've got some record IDs, months, days, years, etc. And so within R, just like Shell, you can download things. And so here's the format for downloading a file. And so we're going to download from this link, and we're going to save it as portal data join.csv. It's a comma separated table. Now, right now, this is just going to save wherever we're currently at. just like shell, you have a directory that you're currently in and doing things in. And so you can change that directory similar to how you can CD around. And so you could CD to your desktop. And the command for that is set working directory. So set WD. And so setting WD within quotes, because when you're passing file names and directory names, you put them within quotes. We could do maybe go to my desktop, and you can tab to autocomplete if you want. And so now if I were to download a file without providing a path, it will actually just put it in my desktop. So you can do something similar to that. You can also go up and under session here, under this dropdown, you can set your working directory manually as well by pulling up a file browser. If you're not super comfortable, maybe you're on Windows and the file directory system is a little bit foreign to you. Whereas if you're on a Mac, it's very similar to how our servers are set up with the home directory and all those things. So whatever way you want, I would suggest moving to your desktop. It's not going to matter. It's a small file if you happen to save it to some random place in your computer, though. Okay, so I've moved to my desktop, and I'm going to copy and paste this because it's a long URL, and execute it. So it's going to go ahead and download. And while it's downloading, now that it's done, we're going to read in that CSV. This is a function that reads a file that's in a CSV format and basically translates it into a data frame. And so we're going to take that, reading this in with this function read CSV, and take that data frame and save it as an object, and we're going to call it surveys. So we will read.csv portal data joined and execute it. Now notice we don't get to actually see the contents yet because similar to using the pipe function or the redirect function in shell, the output that would normally go to your terminal or console in this case is instead saved as that object or that variable. And so just like in shell, it's always good practice to use the function head. So just like there's the head command, there's the function head as well. It's almost identical, except it does the first 6 lines instead of 10 lines, but you can modify that if you really wanted to. So we'll head surveys now. And what you can see here is this looks very much like a table, right? We've got all of our rows, we've got our columns, and we've got content within each one of these cells. Now, one of the things that R does really well is manage the types of data that are contained within data frames. And this can vary from row to row, from column to column. And so you can have things stored in a number of different types of data types. Everything from numeric to character data to logical data, whether it's just true or false. And so it's important to know what those are for each one of your columns because R will assume what they are based on how they look. And so you can actually look at the structure of your data using str. And so we'll look at surveys. And here you can see that for every column we get an output. We also see that this is a data frame. The whole thing is a data frame. And we've got this record ID. It's assumed to be an integer. Sex is a character. Species ID is a character, and you can see that these kind of follow what you might think. We can look at other ways to get information about our data frame. We can look at the dimensions of it if we're curious about how many columns and rows are in it. So we can look at the dimensions of survey with the function dim. And we can see that there are 34,000 rows and 13 columns. So if you tried to open just this basic spreadsheet in Excel with 34,000 rows, you could probably do it, but it would be very slow and it'd be very tedious to scroll around and things like that. If you want, you can play around with these as well. If you didn't want both the rows and the columns, you could use nrow to get just the number of rows and columns to get the number of columns. You've already seen how to head the file. You could also tail the file to look at the bottom 6 rows. We could use things just if we wanted to pull out what types of data are in there. We could use names function to pull out just the names of the different columns that are in there. You could also use this to rename them as well if you wanted to. And if we wanted a really quick cut of the deck statistically, as far as descriptive statistics go, we could use the function surveys, or the function summary on surveys. And here for every column, we actually get some basic descriptive statistics. The minimum value, the max value, all the quartiles, as well as the mean. And so we get that for all of them very, very quickly if they're numeric data. So one of the things that make people love R for using data frames so much is that it's really quick and easy to do all sorts of subsetting of your data frames, both in some really simple ways I'm going to show you, but also by integrating the use of Boolean operators. You could include all the rows that do not contain species equal to a certain name, or vice versa, or greater than a certain length or date. So really nice, quick, and easy ways to manipulate your data and exclude or include different things. So we looked at how functions are always followed by parentheses, and your values and arguments and stuff go within those. For subsetting data frames, the data frame name is followed by a bracket. And within that bracket, the format is something pertaining to the rows that you want, comma, something pertaining to the columns that you want. And in the most simple way, you can think about this as kind of like the coordinates if you've ever played Battleship. Remember in Battleship, you know, your ship could be at A3 or A6 or C7. Here, they're both numbers, but these correspond to row 1, column 1. And so that's a cell where row 1 intersects with column 1. And so if we wanted to look at that, surveys, row 1, column 1, and executed it, that is the value of that cell. And so we could actually head surveys just to confirm that for ourselves. And we could see that in row 1, column 1, record ID equals 1. We could also look at row 1, column 6. Here it's NL, right there, species ID. And we could even pull out the whole column if we wanted, if that's all we give it. So if you only give it one number, it's going to assume that you want that column. So here is all of the record ID column numbers. You can be a little more flexible. You can use the double dot here, so as a kind of like count all the way up to this number. So if we did 1 double dot 3, this is a stand-in for saying 1, 2, 3, or 1, 2, 3, 4, 5, or all the way to 10. And that is the rows for that first before the comma. And then let's say we want the values for column 7. And so here they are. It was M, M, and then they were blank, and then an M, and then they were blank. And so if we were to go head survey again and look at what actually is in column 7, we can see that the sex was actually blank here for some of these. And I'm not sure why that is. I don't really know too much about these data. You can look at the entire row of something if you leave the column blank. So surveys, maybe row 3, but leave the column blank. So now you get the header plus all the column info for that entire row. So this is a nice way to do something. And you could do that with the double dot as well, 3 to 6. And here you can see all of the content that we just subsetted. You could even save this as new survey if you wanted. And so then you could do other stuff with that. And so it's really easy to subset without overwriting your old table and saving it as a new object and doing all sorts of fun, exciting stuff. You can use the minus to actually exclude things. So this has 34,786 rows. So if we didn't have access to the head function for some reason, we could actually make our own kind of silly version of head by subsetting in a way that we exclude rows 7 all the way to 34,786, but retain all the columns by not specifying any columns, and return that. And this is exactly the same as head. It's the first 6 rows. Now, I don't expect you to remember that there were that many rows in the data set, but just showing you how the negative sign actually works for these. So I have a few questions in here for you to kind of try things on your own. The first is to create a data frame called surveys 200 that contain only the data in the row 200. So just like we just did, what we're going to want to do, and I wouldn't even save this as a object until I know that it's working. We're going to say we want row 200, comma, we don't want to specify any of the specific columns. We want all of them. And if we execute that, there it is. So now storing this as an object would be as simple as surveys underscore 200. Execute it, and now that works. For the next one, we want to use nRow to see how many rows there are. Again, we've kind of talked about this already. And use that number to try and pull out the last row in the data frame. So if we use nRow on surveys, we can see that is the number of rows that are in this. So if we wanted the very last one, we could do surveys. We could subset it and ask for row 34,786, comma, keep all the columns. If you just wanted 5 to 8, you could do that. Maybe I'll do that just for this example. And here we can see plot ID, species ID, sex and hindfoot length. And we could save that, whatever we wanted. We could call it last row, maybe. Okay. And then the same thing for the middle. You should be able to figure out what the middle row would be by dividing this number and figuring out where the center of it is. And then same with redoing what we just did with making up how to do a head of our data set. So this number 4 we actually kind of did already. And so I showed you a really simple way to use that, just taking the information from nRow and copying it over. But there's nothing to stop you from using nRow and saving its output as a variable as well. So here we could take nRow of surveys and save that as some variable. We could call it nRow or whatever. And then rather than always typing that last number to get the very last row, we could actually just use that nRow variable as a placeholder, because that number is the same as the one we hand typed there, and get our survey last. We could use nRow divided by 2 to get the middle one. And then we could actually take the negative of 7 to all the way to the end of nRow to also do kind of the equivalent of heading it. So if you didn't do it this way, that's totally fine, because you probably didn't know that you could do it that way. But try and go through these two and copy these down and see if that makes sense to you as well. Okay, and there is a lot more to get into with R. But again, I just wanted to give you just kind of a taste of how it works, show you kind of how to use the R script for executing things, and so you can see how I do things and what I think is kind of working smarter, not harder, by typing directly into the console, which I really strongly suggest you avoid. And then you can always save this script and come back to it later by opening it up just like you would any text file. If you want to learn more about R, go to the Data Carpentry site and follow through really where this R tutorial leaves off. There is many more pieces to this, learning about how to change data types and applying different factors if you're interested in experimental design. This is a great method for and tool for implementing statistical tests, particularly very complicated ones, everything from ANOVA to linear models. And so if you start to like this stuff, please do dive deeper into this. You could consider using R based packages for your final project as well if this is something that really jives with you. All right, thank you.